So in some proofs in analysis, you want to prove something like, some statement that you want to prove is for every epsilon greater than 0, blah something is, there's some statement, some kind of clause or phrase is less than epsilon. It's not necessarily a number, it's just some kind of phrase, and then it ends with less than epsilon. And oftentimes when working for a proof, you might end up proving for every epsilon greater than 0, the same, if you have the exact same phrase, it's less than, say, 2 epsilon or 3 epsilon or some constant times epsilon. Okay, in fact, the constant doesn't even have to be a, well, often it probably will be a natural number, but it could be any real number. But some real number, r epsilon, for some positive real number. And the thing that I want to explain is that actually, once you have proven this, now first of all, if you look at the statement, it doesn't completely match the statement you want to prove. Because let's say you prove that blah, 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 blah is less than 5 epsilon. Well, 5 epsilon is more than epsilon, and you want it to be less than epsilon. But the thing that I want to explain is that if you have proven that for every epsilon, the blah, 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 blah is less than 5 epsilon, it actually implies that for every epsilon, blah, 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 less than epsilon. Okay. So let me explain why this is true. So the trick is, so the quote-unquote theorem is that the statement you proved implies the statement you want to prove. So let's call this star, and let's call this with 2 stars. Then the theorem says that this statement implies, the statement with the 2 stars implies the statement that you want to prove. And the quote-unquote proof of this is So we want to show that for every epsilon, blah, blah is less than epsilon. Well, let epsilon prime be epsilon over r. So we showed that, so this epsilon prime, this is a positive number, right? Because epsilon is a positive number. Then, since epsilon prime is a positive number, you can apply the statement you proved to epsilon prime. Remember, what this statement is saying is that when it says for every epsilon greater than 0, that means for every positive real number. For every positive real number, what you proved is this phrase is less than r times that positive real number. And epsilon prime is a positive number, so you use epsilon prime as that positive number. What you proved then is that the phrase, so then by 2, we have that this phrase, this thing, is less than r epsilon prime. And r epsilon prime is r times epsilon over r, which is epsilon. Right, so maybe I should have said let epsilon be greater than 0. So let epsilon be greater than 0, and then let epsilon prime be epsilon over r. Then, by what you had proven, this thing is less than this phrase less than, you proved this phrase less than r epsilon prime, and then since epsilon prime is epsilon over r times epsilon prime is just epsilon, and then you end up getting that this phrase is less than epsilon. So this sometimes happens when you're using the triangle inequality. You end up getting that something is less than 2 epsilon, and then what you end up doing is everywhere in your proof where you had an epsilon, you change that epsilon to epsilon over 2, and then you just keep everything else the same, and then the ending statement, instead of being less than 2 epsilon, that will turn into less than epsilon. So there are a few places where this kind of thing shows up, and I wanted to clarify that why it's okay if you get something less than like 5 epsilon, right? For every epsilon, blah, blah, blah is less than 5 epsilon. It's sufficient. And how to change the proof to modify this. So what happens in a lot of analysis textbooks is in their proof, right, they're trying to show that you have some phrase less than epsilon. In their proof, they'll divide epsilon. They'll have a statement where instead of less than epsilon, they'll change it to like epsilon over 2 or less than epsilon over 3. And then it's not apparent why you would do that. And the reason is because if they didn't, then you would end up getting less than 3 epsilon or less than 2 epsilon. And then what they did was after that, they replaced epsilon by epsilon over 2 or epsilon over 3 so that the sum at the end, instead of saying less than 2 epsilon or less than 3 epsilon, will just say less than epsilon. Okay? Thanks.